In this class, we are going to discuss about thermodynamics. Okay, what is meant by thermodynamics? Thermodynamics is a branch of physics. Okay, so which is going to deals with heat, energy, heat, energy, work. Okay, so work is also nothing but mechanical energy only. Okay, heat, energy, mechanical work, and temperature. Okay, or these are the basic things which we are going to learn here in thermodynamics. Okay, thermodynamics is a branch of physics which deals with about heat, energy, work, temperature, and how these are going to affect the matter. Okay, so this is what we are going to discuss in this thermodynamics deals about these things. Okay, right. So this thermodynamics is a macroscopic science. It's not a microscopic, it's a macroscopic. Okay, macroscopic sense. What is the difference between micro and macroscopic? Small things if you measure na, that will be called as micro. If you will consider a big container, if all the things are in from the container, then it will be bigger one, right? So then that will be called as macroscopic. What are these things? Pressure, volume, temperature, entropy. So this we all discussed in and discussed as a macroscopic variables or macroscopic particles or macroscopic system. Okay, so thermodynamics is a macroscopic science which deals about macroscopic variables. What are that? Pressure, volume, temperature, entropy, mass. Okay, this all will comes under macroscopic variables. Okay, right. Now we are going to discuss about first heat. Okay, so what is meant by heat? The energy which is transferred between a system and its surroundings as a result of temperature difference only is called heat. Okay, for example, I have one container here. Let's consider this liquid, full of liquid. Let's consider water itself. Now there will be here one molecule is there. No, I'll put fire here. Then what will happen? This molecule will gets heated. It will gets hot. So after that, this molecule will goes there, and that molecule will comes. Okay, it will be exchange. So what is exchanging? Energy is being exchanging. So that's what the energy is transferred between system, in between a system and its surroundings. For example, if you will keep your hand here after the water, above the water, then what will happen? You will observe that some heat, no, you will feel that, you will experience that hotness, right? So with the surroundings it will exchange its energy as a result of temperature difference. As here temperature different, here temperature is different. Okay, so that the energy which is transferred between a system and its surroundings as a result of temperature difference only is called heat. Okay, what is the what heat is a what quantity? Heat is a scalar or vector? It is a scalar quantity. Okay, getting heat is a scalar quantity. So this heat will transfers from hot body to cold body. Heat always moves from hot body to cold body. Okay, the temperature of the hot body decreases. Temperature of the hot body decreases when it loses its temperature or when it will gives its temperature to cold body. Okay, clear? Let's consider here I have object A and I have an object B. Let's consider this temperature is more. Let's 100 degrees Celsius. It is some 50 degrees Celsius. Now I kept both are very near to each other. Then what will be happen? Some amount of heat will comes to this. So this temperature will be decreases. This temperature will be increases. When it will be equal, temperature will gets equal. Then there is no exchange of energy takes place. Okay, that means there is no heat energy exchange that takes place as both the temperatures will remains same. Okay, getting right. So here heat is nothing but form of energy which always moves from high temperature to low temperature. Okay, got it? Right. Next, what is the unit of energy? Heat energy. Heat is nothing but heat energy. What is the heat energy? Whatever the energy it is, joule. SI unit is joule. CGS unit is erg. What is the relation between these two? 1 joule equal to 10 power 7 erg. 1 joule equal to 10 power 7 ergs. What is the dimensional formula for this? Heat energy, m L square T power minus 2. So this is the dimensional formula for heat energy. Okay, clear? Right. Now let's see the temperature. So what is the temperature? Temperature means it is defined as the thermal condition. Thermal condition means whether it is a hot or cold of a body, which determines its ability to transfer heat to other bodies. Okay. For example, same like before, I have body A and body B. So this is 100 degrees Celsius. It is just 10 degrees Celsius. Now more amount of heat will be transferred. Now if you will place both are nearby each other or contact each other, more amount of energy will be transferred. Now object A have 100 degrees Celsius, but B 90 degrees Celsius. Okay, then how much energy will take place? Just 5 degrees Celsius of temperature will be transferred. That means small amount of energy will be transferred. Here high amount of energy, here low amount of energy is being transferred because of thermal condition of a bodies, which determines its ability to transfer, how much it has ability to transfer heat to other bodies. Okay, clear? So what it depends, what it is, temperature is a measure of, very important point, temperature is a measure of hotness or coldness. Temperature is a measure of hotness or coldness of a body. Okay, that is called temperature. So temperature determines, what it determines, from more temperature to low temperature only, heat will be takes place, transfers. Yes, heat temperature determines the direction of flow of heat, A to B or B to A, how it will move. It depends, determines the temperature. Always it will move from high temperature to low temperature. That's what. Okay, what is the SI unit? SI unit of temperature? SI unit of temperature is Kelvin. It is also called as absolute temperature or absolute scale. Unit is Kelvin. Celsius units, degree Celsius will be taken. Okay. And what is the dimensional formula? It may be K or theta. Mostly it will be represented with theta only. Okay. This is about temperature. Got it? Clear? So mainly the energy will be measured in terms of degree Celsius. Okay. Temperature. Got it? Right. Next. Thermodynamic system. So let's consider a system. A system is defined as a region in space. In space means some surroundings, that's all. Okay, it's a space. In this space, I have some system. The region, this is the region which we have in space. So this region may contain a collection of large number of atoms or molecules. Maybe large number of atoms or molecules which are going to be present in the system within a real or imaginary boundary. It might be a container or just assumption. Okay, so in this, what are the molecules or presents, molecules or atoms which are present, then that system will be called as thermodynamic system. Okay, a system is defined as a region in space. The region may contain a collection of large number, many more and more number of atoms or molecules within this boundary. That will be called as thermodynamic system. Okay, example again, it's not only solid, not only gas, not only liquid, it might be anything, large number of collection of atoms. Okay, it might be anything, solid, liquid or gas. Clear? Right. Next I want to discuss about thermodynamic variables. Thermodynamic variables. So what is this thermodynamic variables? Thermo means it's all about heat, energy. Okay, so now thermodynamic variables, what are these variables? What are these variables? Pressure, volume, temperature, entropy, mainly these are the things. Okay, so regarding this there will be a formula, PV equal to nRT. Okay, this is called as ideal gas equation or gas equation state or gas state. Will be discussed about this little later. So thermodynamic system means the system or the region contain a collection of large number of atoms or molecules within a boundary, that is called as thermodynamic system. So here when one will be changes, let's temperature increases, pressure will be changes, volume will be changes. Okay, so mainly we are discussing about, mainly will be discussed about variables. That variables is P, V, T. Okay, if temperature increases, volume will be changes, even pressure is also going to be changes. Clear? So these variables are thermodynamic variables. So here these thermodynamic variables, it depends on the system, this will be varies. So in that first system is open system. Open system, let's consider a container, okay, of water. It's consider water, fully water is there inside. So we are giving some heat to this. When you are giving heat to this, here particle is there, no? This particle is trying to give energy to the surroundings. These particles are giving energy to the surroundings. That means transfer of energy takes place or not? Yes. In this case, in open system, only in open system there is only exchange of energy. So in open system, what's changing? Exchange of energy takes place. Okay. Exchange of energy takes place. Okay. As well as, so if it is boiled too much, then what will happen? Some amount of matter also will goes, no? So some will gets evaporated. That means some evaporating. That means what change is happening? Matter. Okay. Exchange of energy and matter, both are going to be changes. Okay, clear? So in open system, this is the one best example. Open, water is boiling here, so because of that it will gives heat energy to the surroundings and as well as matter. So exchange of energy as well as matter will be takes place, exchange. Okay, this is the open system. Clear? Next, closed system. So in a closed system, same that you can take as a cooker, pressure cooker. So you can take as pressure cooker. So in this you are giving temperature, what will be happen inside? Pressure, volume, it will be changes, right? Right or not? So this will so whatever we are giving, is that coming out? Is that coming out? No. But energy, matter is not coming from out. Inside, energy only is coming. Sorry, energy only transfers. So transfer of energy takes place, but there is no exchange of, there is no exchange of matter. Okay, clear? Understand? There is in closed system only transfer of energy takes place. There is no exchange of matter takes place. Example, pressure cooker. Okay, clear, right? Next, isolated system. What is meant by isolated system? Now you are giving heat now here. So this is the system only, no? In this system, I mean it's the liquid is closed. Before condition also it's closed only, but it's treated as a cooker. Now it is also closed. Okay, here there is a one thing, you are keeping fire, but there is no change, there is no change of position of particles. Why? Energy is not transferring. That means here something which is opposing, there is an something is there, that is called as insulating wall. Insulating wall. So what will be called that? Insulating wall. So insulating wall is called adiabatic wall. Insulating wall is called adiabatic wall. Okay, clear? Insulating wall is called adiabatic wall. What this wall will do? It will not allow the heat energy inside it. Okay, as well as no matter will comes out. Okay, that means here no exchange of energy as well as matter. Okay, that will be called as isolated system. Instead of that, we already knows about this isolated system. Isolation, when we are in pandemic, at the time we came to know about isolation. So we cannot come out, nothing will goes inside it. Okay, no energy will be transfers. That will be called as isolated system. Same thing, no energy is transferred as well as no matter is transferred. Whomever is inside it, that is not coming. Whomever outside, they are not going inside. So best example for this, thermoflask. Thermos flask. Okay, if you will put in hot water or cold water, inside water remains same, there is no change. Okay, that wall will be called as adiabatic wall. Clear? This is about open system, closed system and isolated system. And next, thermodynamic equilibrium. Okay, you know about equilibrium. What is meant by equilibrium? Equilibrium means almost it's kind of rest. If we consider particle, if no many forces are acting on it, even though object not moves, then that will be called as balanced. That is only called as equilibrium position, right? Similarly, here equilibrium means if a system is simultaneously in state of mechanical equilibrium, chemical equilibrium, and thermal equilibrium. If three are there, then that will be called as thermodynamic equilibrium. Okay, equilibrium has mechanical, chemical and thermal. Then that system will be called as thermodynamic. System will be in thermodynamic equilibrium. Okay, what is this mechanical equilibrium, chemical equilibrium and thermodynamic equilibrium? So first mechanical. Mechanical means what? Work only, no. Chemical means reactions. Then thermal. Thermal means heat. Okay, first we'll see about mechanical equilibrium. Okay, what is meant by mechanical equilibrium? In this, there is no unbalanced forces. There is no unbalanced forces. That means sum of total force will be sigma total force will be equal to 0 or sigma torque is equal to 0. We'll discuss this later. So when there is no balanced forces, then we can say that system is in mechanical equilibrium. Okay, next chemical equilibrium. In this chemical equilibrium, there is when a system does not undergo any reaction, that means no transfer of matter, no transfer of matter, no transfer of matter from where? From one position to another position. That will be called as chemical equilibrium. Okay, clear? Next, last and final important, thermal equilibrium. I have an object of A and B, two bodies. It have 100 degrees Celsius. It is 50 degrees Celsius. Kept in contact. What will be happen? This body A will be, body A's temperature will be 75 degrees Celsius. At the time, what about body B? It is also 75 degrees Celsius. Next, what about next? Is the temperature will go still? No. Is the temperature will come this side? No. Both the temperatures attains equal, same temperature. Then this system we can say that in thermal equilibrium. Okay, when there is no exchange of energy between its surroundings, for example, from this body with this surroundings, there is no exchange of energy takes place, then the objects or the system should be in, or we called in, thermal equilibrium. If these three equilibriums are there in one system, then we can say that object is in thermodynamic equilibrium. Okay, clear? Right. So here we discussed just before, there is an insulating wall is called adiabatic. Adiabatic wall means it's just opposition. Then what about one more is there, that is called diathermic wall. Diathermic wall. So diathermic wall is an conducting wall. Diathermic wall is conducting wall. Adiabatic wall is insulating wall. Okay, got the difference between adiabatic and the diathermic wall? Yes.